We're going to talk about proportional versus non-proportional relationships in a linear equation. If it's proportional, one thing you're going to notice is that the line is going to go through the origin. So that means in a graph, my line is going to go somewhere right here in this origin. In a table, if it's going to go through the origin, the ordered pair for the origin is 0, 0. So when my x is 0, my y would be 0. So we're going to look at some examples. Okay, looking at this, these are the ones we're going to end up looking at and graphing and deciding if they're proportional or not. But I can look to see, some of them I can tell if they're proportional or not by looking at the 0. Okay, if, like we just said, if it's proportional, when the x is 0, the y is 0. So that means right now I can already tell that this is proportional. I can already tell that this one is not proportional because my zeros are not the same. So that is not proportional. Okay, that's just one way. Now, that's just a quick glance. Now, if there's no 0 listed, I don't know what my x, when my x is 0, what my y is. So I don't know if it's proportional or not. So let's go ahead and look at some of these. You have this sheet in front of you, and we're going to do some of them together, and you're going to do a couple on your own. So let's start. I'm going to start by graphing this line. So 1 and negative 1/2, 1 on my x, so that would be here, and then negative 1/2, so that means I'm going to go down a half. Okay, so I'm going to go ahead and plot that. Then 2, negative 1, so I would go over 2, down 1, negative. 3, negative 3/2. Okay, in case you're wondering, that would be negative 1 and 1/2. Okay, so I'm going to go 3 and negative 1.5. And then 4, negative 2. So I went ahead and got a ruler and I lined it through those dots and made a line. And I noticed that it does go through the origin. So that's a big clue to let me know that it is proportional. It's multiplicative. I'm multiplying it by the same thing every time. So the question is, what am I multiplying it by? Well, to do that, you can divide. I can say negative 1/2 divided by what? Divided by 1 is what? To figure out what I'm multiplying by. And I notice that, or even knowing that 1 times what is negative 1/2? Negative 1/2. That's what I'm multiplying by each time. So that means I'm multiplying by negative 1/2. So my equation would be, so I'm multiplying by negative 1/2 each time. My equation is going to be y equals negative 1/2 x. So my constant of proportionality, meaning the thing that I'm multiplying by every time, is negative 1/2. Okay, I'm going to do this one now. I'm going to start with negative 2 and negative 1. So that's going to be right there. Then 1 and 1/2. So I would go over 1 and up 1/2. 2, 1. 4, 2. So I went ahead and put my ruler through it and drew the lines. Now my line is not perfect, or my dots were not perfect, but I noticed it is going to make a line and it is going to go through the origin. So it is proportional. There is a constant of proportionality, which means I'm multiplying the x by something to get to y. And after that, I'm done. I'm not adding anything to it. So what is that going to be? What am I multiplying it by? Well, 2 times 1/2, or negative 2 times 1/2 is negative 1. 1 times 1/2 is 1/2. 2 times 1/2 is 1. So that means my constant of proportionality, my k, is 1/2. So my equation is going to be y equals 1/2 x. So again, the constant of proportionality is 1/2. Okay, let's do another problem. Now looking at this, I know that it's not proportional because when my y is 0, my x is not 0. But is it going to make a line? So let's graph these points. So I'm going to start with 1, negative 1, 2, 0, 3, 1, and then 4, 2. Looking at that, it's definitely a linear relationship, but it's not proportional. I'm not multiplying the same thing every time. So I'm not saying 1 times something is negative 1. Now looking at it, do you see a relationship between x and y? Yes, there is a relationship. I'm subtracting 2 each time. And remember we said whatever you're adding by is your y-intercept? Well, when I notice when I'm across the y-axis, it's at negative 2, isn't it? So I'm subtracting 2 every time. Now this is because it's an additive relationship, but my equation is y equals x minus 2. Now that's not every relationship. This is just that because it is an additive relationship. But what if it's not just additive or multiplicative? Okay, I'm going to start graphing this one, 0, 2. Oh, that would mean I'm adding 2 each time, right? Oh, wait a minute, but 1 plus 2 is not 0. That doesn't make sense. Okay, so then 1, 0, 2, negative 2, 3, negative 4. Okay, let's make a line. Okay, so I did this. It is a linear relationship, meaning it makes a line, but it is not additive or multiplicative. Now, we're not going to get into the whole thing right now. That'll be something you'll learn later. So right now, we're just going to say it's not proportional. Okay, now, just in case you're wondering, the equation for that is actually y equals negative 2x plus 2. But don't even worry about that right now. That's a while down the road. But I wanted you to see that it does still make a line, but I'm not just adding or just multiplying. It's a combination, but it's not proportional because if it's proportional, it's just multiplying something. I want you to try the next 2 on your own and then check to see how you did.